Alright, so as Coley rides the bike, there's a magnet inside that's spinning in a circle, and this is changing the B field, which then induces a current that goes through. So, these three are in parallel switches, so you can turn each one on or off, and the other one will still work, along with this.
Turn this switch on, and if the person pedaling pedals faster and harder, these will turn on. Then if you turn, why are these, where are the,
These things are...
Sure. Okay. So our ammeter is in series with the light bulbs because the current is the same across each resistor in series. And if you unplug the ammeter, the series would break and none of the light bulbs would work. And our voltmeter is in parallel with the light bulbs because the voltage drop is the same across each resistor in parallel. And our ammeter, as shown here, is in series, and our voltmeter is in parallel with each light bulb.
Go away!
awesome.
Alright.
Yeah, you can get a close-up of that too if you want.
Start pedaling again, we'll have it turn on.
Since we have our voltmeter in parallel with all the other resistors, if I was to come over here and pull it out, everything will still work. So, because the ammeter is in series with the four resistors, well, the three resistors on the voltmeter, if I was to come over here and pull out the ammeter, the series, there's no way for the current to finish. Go through, so it won't fuck me.
Go. Alright, so the more Joe pedals, the more mechanical energy is created, and thanks to the conservation of energy, the more electrical energy goes through our current, goes through our system, increasing the current in our ammeter.
Alright, so how this works is there's mechanical energy created by the bike, which turns into electrical energy, which goes into our power source. Then as the current goes through, it goes through to all four it goes through our three switches and then through our voltmeter. So then these are all in parallel with one another. So if I was to turn this first switch on, the current will go through, and these are all off, the current would go through this wire to these two light bulbs. But what's important with the fluorescent light bulbs is that they have to be into gold and out of silver. But one of the issues we had when we first did the project was we had it going into silver and out of gold for one of the light bulbs, so it wasn't working. So then we had to switch everything around again. But if these are all on, these will all work because it's all in parallel. And then as the current goes into this plug for the blower, it comes out, goes into all four of these wires that are in parallel, which all go into our ammeter, which is in series with everything else in the circuit, which then goes back into our power source. Put the correct.
Okay, so when the two lights are on in our circuit, the circuit is in series. The voltage is 14.81 millivolts, and the current is 0.002 amps. V equals IR, so the total resistance is 0.0148 volts divided by 0.002 amps, and you get 7.4 ohms. Am I fine? Okay, yeah. When all the lights are on, the circuit is in parallel. The voltage drop is 14.21 millivolts over each group of resistors in parallel. The current is 0.004 amps, so the total resistance is voltage over current, and we get 3.55 ohms. This makes sense because the resistance in a parallel circuit should be smaller than the resistance in a series circuit.